When k is equal to 0, the poles of the GSHS becomes the poles of the closed loop system. So this is like when k is equal to 0, the pole of the closed loop system is going to be here. Okay. And we also know that as k moves toward infinity, at k equal to infinity, pole of the closed loop system is actually the 0 of GSHS. So at k equal to infinity, the pole is going to be here. Okay. So we want to know like how when k changes from 0 to infinity, how the closed loop pole is going to move. We know that it's going to move from here to here, but how? Is it going to go from here to here, from here to here, from here to here? Okay, so we know that if we know that let's say like if we just like pick a random point here, if the pole of the closed loop system should exist here at this point, we know that this should be satisfied, right? This should be satisfied. So the phase of GS times GHA should be equal to 180 degrees, right? Because this is basically 1 plus k GS GHS should be equal to 0. So it means that these two conditions should be satisfied. So let's just write this down. So the phase of S minus 1 divided by S plus 3 should be equal to 0. So if this point is S minus 1 would be this vector. Okay. S minus 1 would be this vector. Sorry. S, so because this is S, this is 1, right? S minus 1 would be this vector. This is vector operation. Let's just, this is S, this is 1. S plus 3 would be this vector. Let me actually do it in the positive half plane so that it's more clear. So let's say this is S. This is S minus 1. This is S plus 3. Okay. So if, sorry, this is supposed to be 180 degrees. So the phase of S minus 1, which is this vector, it's gonna be this phase. This is the phase of S minus 1. And phase of S minus 1 minus phase of S plus 3 has to be equal to 180 degrees. Okay, this is phase of S minus 1. This is phase of S plus 3. Okay. So this is this angle, and this one is this angle. The difference between them has to be 180 degrees to have a pole of the closed loop system. Can you guys tell me if, like, for this point, this is valid or not? Is this angle minus this angle equal to 180 degrees? Or can it be equal to 180 degrees? It can't. This is definitely smaller than 180 degrees, and we are subtracting something out of it. So it's definitely smaller than 180 degrees. The only points in the plane that could have this relationship satisfied are the points between the 0 and pole, right? Because like if you find like any point here, this angle is 180 degrees, this is 0, so this is satisfied, right? So the pole of the closed loop system are basically gonna move from here to here on this line. As k changes from 0 to infinity, the poles of the closed loop system are gonna move from here up to here, okay? If the poles of the closed loop system are on the left-hand plane, the system is stable. If they move to the right-hand plane, the system becomes unstable. So we want to know at what point, for what value of k, the pole of the closed loop system is gonna be on the right-hand side. So like, what's the maximum k that we can have so that we are still stable? We are still in a stable system, okay? So we basically want to find the value of k at which this happens, okay? So this is actually not, I hope like everybody got this part, like why this is called the root locus of this system. It's just like it moves from this pole, it ends at this 0, right? And it's just like one line, okay? Root locus of any system has many branches. For this one, it has only one branch. The number of branches are always equal to the number of closed loop poles. Because this system has only one pole, we only have one branch, which moves from, and the root locus branch always moves from a pole of GHS to a 0 of GHS. Okay, as k moves from 0 to infinity, this is how the poles of the closed loop system move. We want to know at what point the system becomes stable. For what value of k the system becomes unstable. So for all these points, k is equal to 1 over GHS. So like we have k is equal to 1 over magnitude of s minus 1 divided s plus 3, right? Or let's just simplify this. K is equal to magnitude of s plus 3 divided by s minus 1, okay? At this point, s is equal to 0, right? So this means k is equal to 3 at this point. So for this system, as long as k is between 0 and 3, the closed loop system is going to be stable. But if you increase k further than this point, you have a pole on the right hand side. So